replication has sort of its own setup area within the system. So we're going to go to departments. And dynamic retail and administration. And so then we have a replication section here. So first we're going to go to replication setup. And so each database is going to have its own instance of a replication setup record. So that's one of the only records, or maybe even the only record that's going to be unique per database. And this is how we actually know which database we're in. So I've created a replication setup here where we're saying that our local database is head office, and we'll get to the database setup in just a second. But when you come here, what you're going to do is sort of create a database record for your head office, and then say, okay, this is my head office database, and so everywhere in the system, it'll know that we're in that particular database. Otherwise, there's no way for the system to know.
Okay.
There is a the way that the replication actually works from a technical standpoint is that changes are tracked, and those changes can be tracked in a variety of different mechanisms, and we'll get to that in a little bit. So you can only track changes, or you can send all the data every time, or whatever. But we'll take a look at that in a little bit. But so we've got some data that needs to be transmitted, and so what happens is it's actually broken up into individual messages, and then those messages are transmitted from the database where the changes were made. And the replication system has a sort of a capability to make sure that those messages arrive, or are actually processed in the right order, and that's what that forced sequential processing flag is for. So if you can imagine a situation where we're actually tracking differences in a table, where a user changes a customer name from John to Bob, and then changes it from Bob to Fred, and so each of those changes is going to get logged and need to be replicated. But we don't want to have to send all the customers every time. Instead, we're only going to send those that have changed. And so if you create a change message and say we're going to change from John to Bob, and then another change message says we're going to change from Bob to Fred, they have to actually be processed in that order, in sequential order, because if you do it out of order, then not the most recent change will actually be applied to the database last. And so this forced sequential processing box will cause the system to go into a mode where if it misses a message for some reason, so if message 5 arrives, let's say, and we've never seen message 4, it'll actually generate a request to the sender and say, hey, I need message 4, and the sender will resend message number 4, and message 5 won't get processed until message 4 is received. So it has its own sort of retry and maintenance technology built into it, so that you're able to make that happen. So you're always going to want to turn on that forced sequential processing. As the replication is doing its work, it can actually log what it's doing to either the Windows event log or to email.
Mm-hmm.
And so the logging level determines what kinds of messages are going to get logged. And so it's useful because sometimes these replication systems break down for whatever reason. You know, you've replicated a customer from one database to another, but that customer's posting group doesn't exist, let's say, in the target database. And you forgot to replicate your posting groups. So that customer isn't going to be able to be created in the target database because one of the related records is missing a setup. So that's going to generate a replication error, and if nobody is being notified about those, then it's possible that nobody would ever notice. And so then the replication will just sort of keep happening, but the messages won't get processed because it'll get hung up on that one that it couldn't work through. So letting somebody know about replication problems is generally a good idea. So the notification mode here could probably be set to something like low. High is very chatty. Like there's a lot of messages come through on high. So every time it checks for new messages, every time it receives a message, every time it processes a message, it'll let you know. And so you probably don't want all those emails coming through. You also have the ability to use the Windows event log on the nav server to log those messages. And so that could be useful if the IT department at the company was using various server administration tools to monitor the event logs on servers, so like System Center or something like that. If they're using a tool like that, then you can log these messages to the Windows event log, and then their normal tools will pick it up, and then you're not relying on someone to check their email. So there's a way to make that a little bit more automated and sort of enterprise grade by using the event log. Priority data. So when we get to the actual data part of this, you'll see that certain data can be flagged as priority. And so priority data gets transmitted every, in this case, 2 minutes, no matter what. So we don't have to set up a special schedule for it. We don't have to say, we only want to send this on Monday, Wednesday, Friday. Like, we don't have to schedule it. The system will send it every 2 minutes. And so the reason that priority data is useful is because there are some kinds of records where it's really important that they get transmitted as soon as possible. So those would be things like voucher entries or gift card ledger entries, where you want to make sure that all of the other stores know that a voucher or a gift card has been used, because if a customer shows up with that gift card in another store, you want the other store to know about it. So that kind of data needs to be replicated on a much more frequent basis than something like an item, which you could probably do daily, for example. Okay, so message dispatching. When we get to sort of the various types of replication, you'll see that I'll sort of go into. Some are more event-driven, and some require fetching. So you know how some email services on your phone are push, where the phone gets notified when you have a new email, versus some where it has to actually go out and actively fetch them. So like every 15 minutes it'll check for new mail, versus like if you're using an Exchange server, the server lets your phone know that you have a new message. So there are replication methods that are options that work in both of those ways. And so if you're using one where it has to actually go out and look for messages, then you can set the fetch interval to however often you want it to go out and check. Maybe every 5 minutes it'll look for new messages arriving, versus the transport mechanism telling the system that a new message has arrived, and then the system can just process it. So that's obviously preferable, but isn't always available, as we'll talk about.
Okay.
Subject for data is if you're using email replication. We don't need to worry about that. We're not going to suggest that you use that. And then the replication system uses AES encryption, also known as Rindal. And so the data is compressed and then encrypted in the messages that get sent from one database to another, just so that we make sure that if it gets intercepted, or if somebody was watching the wire, that we're not leaking sensitive company information. So if you leave that blank, it'll use just sort of a default key that comes with the system, or if you fill in a value there, that's the key that it will use to encrypt the data. So one thing to know is that if you do put a value there, you have to put the same value in every single database so that they can talk to each other. And you can't change it. If you do need to change it, then you basically have to wipe all of the replication history and start over again. The reason is because of that sort of message retry technology, and because if you bring a new store up, it will actually be able to process old messages that were sent from the head office before that store was even brought online. And so those messages actually stay in a history, and the messages themselves are stored with whatever encryption key they used at the time that they were sent. So if you change the encryption key, then those old messages won't function anymore. So if you do find that the key needs to be changed at some point, just know that you're going to have to wipe out all the replication history and restart all the replication from scratch if you have to change the key. And then, of course, if you change it, you have to change it in all of the databases at the same time.
Okay.
All right.